Okay, welcome to trigonometry. We are looking at some problems that are law of sines or law of cosines. So I have a poorly drawn triangle here, and we have some measurements here. So the idea here is the goal is we have to solve for the obtuse angle x. It tells you in the givens that x is obtuse. Okay. Okay, and then we have to go ahead and figure this out. So add two decimal places. I think that's what I said here, two decimal places. Okay. So we're going to have to figure out the law of sines here. We have to figure it out. You should know the law of sines, right? And that's saying that the sine of A over side of A is equal to the sine of B over the side of B. Okay, and it doesn't, we could rearrange this however you'd like to, and that's okay. So the idea with law of sines is you need an angle and the opposite side in order to set this thing up. So we're going to say the sine of 15 degrees is to 7, whatever units this is going to be. I think it's in meters. Okay, we'll make it in meters now. Okay, is equal to, and then we have sine of x, which is going to be in degrees, divided by 12. Okay, so notice we have angle over side, angle over side. Okay, we've gone ahead and set up the one ratio that we know, which is going to be this ratio and this side. And then we're going to set that against the ratios that we don't know, which is going to be this side and this unknown angle. And we're going to solve for that unknown angle. Okay, and that's pretty much what we do with this, right? So, yes. All right, so let's go ahead and do some algebra to solve for this. So we say that we have 12 over 7 times sine of 15 degrees is equal to the sine of x. All right, we're going to need a calculator for this because that's what we do next, right? So we'd say, okay, we have 12 divided by 7. Let's go ahead and do this. First off, let me go ahead and make sure, are we in degree mode? We sure are. Your calculators probably do that automatically, but we have 12 divided by 7, okay, equals answer times sine of 15 degrees, right? We just kind of, no, not 75, I want 15. 15 degrees. Okay. And we kind of have to have this as a value. I'm just going to write this down to 4 decimal places. You always take these things out to 4 decimal places as an intermediate value. But normally I'd like to leave it into the calculator, but for the sake of showing us how to do this, we're going to say this is 0.44. Let's see, what was the next couple of 4 digits? 37. 4437. And that was equal to sine x. Now what I'm going to do is I'm going to take the inverse sine of both sides. So we have the inverse sine of 0.4437 is equal to x. Let's see what we got. Okay, so we have second function sine, so let's have sine inverse, and my second function answer, which we'll put in as 0.4473689 and 6897916. I'll put all the decimals in there. So we'll be having a fairly accurate answer. And then the answer we got was 26.3, says two decimal places, so 26.34 degrees. So 26.34 degrees. Now, is that an acute angle? It most certainly is not. So sometimes with law of sines, you get two possible triangles. This is actually the only kind of problem that will actually lie to you at this level, because sometimes there is no triangle and they like, here, figure out the next side. And you're like, there is no triangle because this side doesn't exist. I can't do that. And that's okay. Okay, that's one of those things that they do to you later on in your educations, is that the math textbooks frequently lie to you. But in this textbook, the only place it will lie to you about triangles is going to be a law of sines problem. Okay, so this is not an obtuse triangle. So what we have to do is we have to take 180 minus 26.34, right? Because we need the angle in the second quadrant that's actually going to give me this. So I have 180 minus my answer, okay, equals, and I ended up with 153 we'll say 0.66 degrees. Okay, so we have 153. So my angle x is equal to 153.66 degrees. That's the answer I'm going to go ahead and report. Okay. One of the things you could do is, like, just in case you don't believe me, and I wouldn't blame you if you didn't, you'd say, okay, well, I'd like to know what the sine of that angle is. We have sine of that angle. And what do you think it's going to give me? I think it's going to give me 0.44367 here. So, oh, what do you know? It gives me 0.4436, 0.44369. So it gives me the same values. One of them, when I just take the inverse sine, it's in quadrant one. You have to say 180 minus that to get the one in quadrant two. Now, 153 is more than 90 degrees. That is an obtuse angle. That's why I know this is the correct part of the answer. Okay, so that's how you do a problem like this. There will be lots of them. So good luck with doing the problems. Practice with them. What you're looking for is law of sines. Okay, and you're looking for something called ambiguous um, case. Okay, that if you want to practice more, that's the kind of thing you're looking for. You don't just type in law of sines because they do that to you. But we have a side angle. You could spell that a different way and figure out why this is such a pain in the yes uh, for this triangle. But you're looking for what they call the ambiguous case. Now, when I wrote in the exams, I don't want you to have to write down two triangles because that gets to be a little tedious. So I usually put a little hint in there to say it's an obtuse angle so that you can narrow down the angle that you want. That note, thank you very much for watching the video. I will see you in the next one. Okay, good luck.